Alright, I want to work a problem here that's a real thought question. It requires quite a bit of knowledge about neurobiology and an understanding of how these things work. So the question says, now that we know what a graded potential is, build a neuron that has 12 synaptic inputs. Draw the cell body plus some simple dendrites showing where the different presynaptic terminals are connected. Each synapse can produce a graded potential of 2 millivolts at the postsynaptic membrane every time an action potential arrives presynaptically. Also, threshold is 7 millivolts above resting potential. Of the 12 inputs, 4 are inhibitory postsynaptic potentials and 8 are excitatory postsynaptic potentials. It says arrange the inputs in a way that the neuron would reach threshold and explain how you arrange them. Okay, well, the first thing I'm going to do is I'm going to draw the cell body, the dendrite, and the axon hillock, and the axon. And it's not going to be pretty. There's nothing to ride home about here. I'm essentially just going to draw a cell body, I draw the axon hillock, and the axon, and I'm going to draw a simple dendrite coming off of the cell body. So essentially that's my cell body here. This is my axon here, this is my axon hillock, and this is my dendrite. So with that said, it says there's 12 synaptic inputs, okay? So I'm going to draw 12 synaptic inputs, okay? And I'm going to arrange them in kind of a specific way, and I'll explain why in a second. But first I just want to kind of draw them. So here's 1, 2, 3, so there's 4, and here's 5, here's 6, 7, 8, 9, one more over here for 10, and there's 2 more over here. Now, mind you, this question is quite subjective, okay? So you can really arrange this almost any way you want to, as long as there's 12 of these here, and as long as you know that 8 of them are going to be excitatory and 4 are going to be inhibitory. So the next thing to do is start determining which ones are excitatory and which ones are inhibitory. And the only real stipulation I'm going to have on that and on myself to make this problem work out is to have enough of these excitatory postsynaptic potentials close enough to the axon hillock. Okay, remember, the closer these are to the axon hillock, the more influence they have. Because the graded potential created by this, that change in membrane potential, that 2 millivolt increase or decrease, depending on if it's inhibitory or excitatory, is going to make a big difference depending on how close it is to axon hillock. Because remember, graded potentials fall off with distance and time. Okay, so the further I am from the axon hillock, the less influence it's going to have. Okay? So the main thing that I'm going to first stress is that I'm going to have enough excitatory postsynaptic potentials close enough to the axon hillock in order to reach threshold. Now remember, threshold is a total of plus 7 millivolts above normal. Okay? This is threshold. So that's threshold, and plus 2 or minus 2 for an excitatory postsynaptic potential or an inhibitory postsynaptic potential, okay? Depending on what's going on here. Now, what I want to do is just start labeling these. So I'm going to say that this is excitatory. I'm going to say that this also excitatory. I'm going to say that this is excitatory. Now there, 4 excitatory postsynaptic potentials. And if I'm adding these up, so it's plus 2, plus 2, plus 2, plus 2. So 2, 4, 6, 8. Okay, look at that, 8. That's enough to reach threshold. So I'm already kind of fulfilling my requirement, my first requirement, which is to kind of have enough of these excitatory postsynaptic potentials close enough to the axon hillock in order to reach threshold. Now, I want to start labeling also the other excitatory ones and the inhibitory ones. And I'm going to put one inhibitory one, okay, right there. And then what I'm going to do is I'm going to give another excitatory one over here, another excitatory one over here. And that accounts for what? This is 4, 5, 6. I got 2 more excitatory postsynaptic potentials, so maybe I'll label those 2 as over here. Now, mind you, this is far away. Okay, this is far away from the axon hillock, so it's not going to have as much of an influence. Okay, I'm going to make this one inhibitory, and I'm going to make these 2 inhibitory. Okay. Now, the next thing to talk about is how would these need to fire in order to reach threshold, okay? And I'm just going to explain that. I'm not going to write it all out. It would take far too much time and space and everything to write out, and it would take my handwriting would be horrible. But I'm going to explain what's going on here. Okay, look. 2, 4, 6, 8. Okay, so we got enough to reach the +7 millivolts for threshold, right? Now, these would all need to fire, but not at the same time. The big common misconception about problems like this is that all of these excitatory postsynaptic potentials, all of these action potentials are firing at the same time. It's not true, okay? Yes, it may seem like the same time for us because we're talking about the milliseconds. We're talking about very, very rapid processes. But the truth is, it's not, okay? First, this one would fire. Then this one would fire. Then this one would fire. Then this one would fire. So if they would go in order, essentially. All right? Each one building on the other. Because remember what I said about these, and I'll write it down right here. So excitatory postsynaptic potentials, they add up. Okay, they're additive. That's what I said. They add up. And they also fall off with distance and time. So if this one fires, this one fires, this one fires, this one fires, essentially this one's going to allow this one to fire, allow this one to fire, allow that one to fire, and this is going to total up to 8 millivolts, okay, which is plenty to reach threshold, exactly what we need, okay? And they're going to fire one after the other to produce, each action potential is going to fire one after the other. Very important point. So the other thing is that the slight difference in the timing, okay, when the excitatory postsynaptic potentials occur, allows these excitatory postsynaptic potentials to be additive. Okay, so they're going to add up, and I've already said that, but again, I want to stress it because it's extremely important. Now, the other key is look where this inhibitory one is. Okay, so this is going to do minus 2 millivolts. Now, you might want to explain why and how this is going to operate. So let's say I don't want to reach threshold. Let's say what I want to do here is I want to inhibit this. I want to inhibit this axon from firing. Okay, I want to stop this process here from occurring. I want to stop the action potential from occurring here and moving in this direction. All right, I want to stop that. Now, if I want to stop that, what do I need to do? Well, I need to have this inhibitory postsynaptic potential, this action potential, fire. And I need to have it fire slightly ahead of this other arrangement here. Okay? So if I'm having these, 1, 2, 3, 4, I have to have this thing here fire ahead of this process up there. And the reason I have to do that is because I need to inhibit it. And the only way I'm going to prevent this from reaching threshold is to essentially not allow it to get there to begin with. So this would have to fire first. Okay, and it's close enough to the axon hillock to directly affect it. And that's the whole point. So as long as it fires slightly ahead, it would be able to prevent the action potential. Okay, it would be able to block the effects of the excitatory postsynaptic potentials. And that's pretty much what you need to explain. These other ones out here are kind of like just here for not for any real purpose, okay? They don't have a great effect on what's going on in the process. What it really is making sure you have enough excitatory postsynaptic potentials occurring close enough to the axon hillock to reach threshold, and then having an inhibitory postsynaptic potential close enough to the axon hillock so that you can prevent this group from firing, or that you could prevent this from reaching threshold. That's the whole point, okay?